Welcome back. This is Mrs. Rubright with Advanced Geometry. Today's lesson is 4.4. Prove triangles congruent by side, side, side. Alright, so use the side, side, side congruence postulate. Write a proof. So you have that it's given that KL is congruent to NL. KL is congruent to NL. So those are given. Let's make it in a color that you can see better. Then it says KM, segment KM is congruent to segment NM. So they're telling you this. So that's what they've given you, right? This was given. So the first thing of your proof, line 1, you put this for your statement, your reason, given. Then what comes next? How about, do you guys see this right here? LM is congruent to LM. I'm writing it in the same order because I'm going from 1 mark to 2 marks. LM, 1 mark to 2 marks, LM. LM is congruent to LM. Why? Reflexive, right? Same thing equaling the same thing. So that's step 2. LM is congruent to LM, reflexive. Step 3, proof. Why? Side, side, side. The triangles are congruent by side, side, side. If all 3 sides are equal, then they're equal. A side, side, side congruence postulate, and you're done. This is as a paragraph proof. This is as a 2-column proof, even though it's kind of messy, but you get the gist, right? You guys understand it? You get it? Okay. Decide whether the congruent statement is true. Explain your reasoning. So are these congruent? Well, they definitely have side, side, side. So now it's just up to, did they write it in the right order? Well, let's see. D, F, G. D, F, G. They went up 2 marks, down 3 marks. Up 2 marks, down 3 marks would be H, J, K. H, J, K. They wrote it in corresponding positions. So yes, this congruent statement is true by side, side, side. However, the congruent statement is true. Explain your reasoning. All right, well, we know that AB is congruent to nobody, right? So let's start somewhere else so we actually can do a little bit of this. So we know that BC is congruent to DA. We know that AC is congruent to AC is congruent to CA, right? These are not congruent. So unfortunately, no, these are not congruent because they don't have side, side, side. They just have 2 sides, not all 3. So they're not. Ooh, sorry. So that was what we were given. We were trying to prove that they're equal, but unfortunately, they're not. Okay? All right, so decide whether the congruent statement is true. Explain your reasoning. So we are given that PQ is congruent to SR, PT is congruent to ST, and QT is congruent to RT, right? We're given all of that in the picture, right? They're marked. So we write all that, and the reason is given. We're trying to prove that these 2 are equal. So here's our proof. We write this out, that they're given. And then we write the proof statement. So this is only a 2-step proof. So literally, if I had a statement and reason column, these are my statements. Here's my reasons. Statement 1 is all that. Why? Because it's given. Statement 2 is my proof statement. Why? Side, side, side congruence postulate. Make sense? They gave you everything you needed to know. That is the easiest proof you'll ever have. Here's my givens. They're equal. They're congruent. This is why. Side, side, side. Which of the coordinates of the vertices of the triangle are congruent to this triangle? So which of these are congruent to this? Well, let's look. So I had -1, 1, -1, 1, 2, 3, 4, 5. -1, 2, 3, 4, 5. Are these congruent? Well, our original was 1, 2, 3. 1, 2, 3, 4. And if it's a 3, 4, do you guys remember the special right triangle? A 3, 4, 5 triangle, right? Special right triangle. Anyway, so let's look at our new one. This one is 1, 2, 3, 4. 1, 2, 3. This one's a 3, 4, 5. So that one is definitely congruent, right? It's a 3, 4, 5. We could look at the other ones. So let's try the next one. -2, -1, -2. 1, 2, 3, 4. -7, 4. -3, 4, 5, 6, 7, 4. And -4, 6. -1, 2, 3, 4. 1, 2, 3, 4, 5, 6. One, 2, 3, 4, 5. This is a 5. Now, is this a 3 and a 4? Let's see. If I did a cute little Pythagorean theorem, I have a 2 by 2. So this is going to be 2, 2, 2 rad 2. If I did a cute little Pythagorean theorem here, I have 2, 2, 2 rad 2. That's a 45, 45, 90. 2 rad 2 is not 3. Therefore, the second one cannot be it. If I did the next one, -1, 2, 3, 1, 2. -1, 1, 2, 3. -1, 2, 3, 1. Is this going to be a 3, 4, 5? It has a 1, so definitely not, right? -7, 7. -1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. -7, 9. Well, we already know that we have a side of 2. Is 2 and a 3, 4, 5? No. So it has to be A. Explain why the bench with the diagonal support is stable, while the one without the support can collapse. Okay, so think about these two guys kind of getting all rowdy and like rocking back and forth. Can you kind of picture these legs being able to kind of go like this and collapse, where the whole bench can just go down? It can, because the bench with the diagonal support forms triangles with fixed side lengths. By the side-side-side congruence postulate, these triangles cannot change shape. So the bench is stable. So think about it. When you put that horizontal support, it locks these two into place, because if these two are connected, it can't wiggle, because there's no way, if they have the same 3 side lengths, you can only get one triangle out of it. Like you can't bend it. It's not gonna happen. So the bench without the diagonal support is not stable, because there's many different possible quadrilaterals with those given side lengths. Does that make sense? You could come up with tons of different quadrilaterals with those side lengths, any set degree. But with this, you can't. Okay, so you want to get those triangles. Those triangles help you have stability. So when I was getting hurricane windows installed in my home, the door wasn't closing properly to my French doors, and I was kind of upset about that. I was just like, this isn't working, like this isn't how it's supposed to be. And they said, oh no, it's perfect, it's perfect. And I was like, actually, if you put a 90-degree, like those little triangles, that carpenters and stuff have, like if you put that in the corners, you can see that they're not plumb and flush. They're not at perfect 90 degrees, and that's why it's not working. And I get that it's really hard to do that, because when you have a door frame, it has wiggle room front to back, right? It can twist kind of front to back and left to right. So unless those angles are 90 degrees in all 4 corners and perfectly level horizontally and, vertically, like front to back and left to right, then you're going to have some issues, and the door's not going to close properly. Who wants to spend all that money and have a door that you have to manhandle and really like slam to get closed and to stay closed? Nobody wants to do that. So it's really important that you have that stability. So when you're installing a frame, a nice easy trick that I told them, even though this is their job, not mine, is I was like, well, if you put a horizontal support beam while you're installing it, it'll keep the door frame stable so that when you install it, it doesn't have that bend. And so it'll make it a lot easier to install, which is why my installers had absolutely no trouble installing any of the windows. Those they did really quickly. And the reason is, think about it, the glass in the window keeps that object stable because it kind of acts as those horizontal supports, right? Because the glass is not going to prevent, it's going to prevent it from bending left, right, front, back. So when you're installing a door, though, they only install the frame without the door. So it has a lot of play. And that's why it becomes much more challenging to do. So when you actually get into the real world and are doing home improvements and stuff, you will be shocked how much you do end up using and relying on from geometry class. This is some of the stuff that you actually will use during your lifetime. So, determine whether the figure is stable. Explain your reasoning. Because those guys kept telling me, oh no, it's perfect. And I was like, no, I teach geometry. And I'm telling you, they're supposed to be 90-degree angles, and that's why it's not closing properly. And like, I literally started you know, coming out with like proofs and theorems, and then they were like, oh, okay, we'll fix it. But they weren't going to at first, because they were just like, yeah, no, it's good, it's perfect, that's how it's, no, it's not. No, it's not. Determine whether the figure is stable. Explain your reasoning. So is this stable? Is it stable? Well, let's stay right there. No, it needs that diagonal to kind of lock it into place. Think about it. Like, if I had this, couldn't you like go and kind of wiggle it back and forth, and it could like become like almost like a parallelogram and stuff, right? It can get slanted. But once you nail in an extra piece of wood going straight diagonally across this, it's going to then lock it into place. So how about here? It's ugly, but is it stable? It is stable. You can't get any wiggle room out of that. That turns it into two triangles. Now this thing is stable. You cannot change its shape. How about here? No, it is not stable. It's missing one thing. It needs one more line from here to here. If you add that in, then it's all triangles, and then it'll be stable. But without that extra horizontal or diagonal support, it's not. Okay? So it's not stable because the lower half does not have a diagonal support. Are you guys okay on this? So that is your second lesson of today. This lesson is on 4.4, Prove Triangles Congruent by Side, Side, Side. I hope you guys enjoyed the lesson. Have a great day. Like and subscribe.